Hi, welcome to my blog. My name's Tom Shue. Today I'm going to do a tutorial about color and color spaces. If you look on your screen in front of you, you're going to see a couple diagrams. Now these aren't accurate diagrams, they're just a simplified version of a color gamut space that I want to use to explain what's happening in color. In your camera, you'll have a couple settings. One is for sRGB and one is for Adobe RGB. Liken those color spaces as to a box of crayons. In the small box of crayons, the sRGB color space, you have all the reds and the yellows, oranges, greens, blues, and purples. And liken this to the 64 box of crayons, in the Adobe RGB, you have all the same colors except you have a bigger box of crayons. Maybe you have the 120 piece crayon set. Now here's where things get a little confusing. A standard monitor, the internet, the web, only works in sRGB color space. So all these extra colors that are spread out, or a wider spread of colors, are wasted because you can only view this color space when you're working inside of a monitor, you're working inside of a print. Okay, now you can buy special monitors. They're called wide gamut. If you notice, this is wider. These colors here between purple and red are a wider space than the red and purple colors here in the sRGB. Now I'll explain to you what's going to happen here. In another diagram, we'll move over to this one. This is an actual gamut map. This is what you would get if you profiled devices and looked at color. Okay, so for example, if you look at this diagram, I hear this horseshoe shape here. These are the colors that the human eye can see, okay, and they fall all inside here, so don't pay attention to these triangular lines. They're only defining other color spaces. So in Lightroom, the default color space is ProPhoto RGB. Well, we know that our monitor can only see in sRGB, which is this triangle right here. Okay, so all of these other colors, they fall outside the color gamut of what you can see on your monitor, or what can be used in a print in most cases. In some cases, the sRGB profiles can actually have colors greater than what are available in Adobe RGB. And here's the example here. If you look at this Adobe RGB, you can see this triangle is here. Okay, well, look at this matte paper. Say if you're doing a sunset image and the oranges and yellows are in your picture, you can see that this falls outside and it can create colors that are possible inside that color space that are not possible inside the sRGB color space. They would fall in the ProPhoto. So you could actually print colors that are available outside of a wider gamut. I know it's kind of confusing, but the way it works is each device is speaking a different language, and it's the computer's job to turn those languages into one language that everything can speak. So let's give you some examples. Say your computer, your monitor, which is an sRGB monitor, is speaking English, okay, and your camera is speaking English if you have it set to the sRGB space. And then if you hand a file off into Photoshop in the sRGB space, it's also speaking English. Well, if you try to hand a file off into Photoshop that's ProPhoto RGB, now you're asking it to understand Russian or Chinese. You see, there's no words to describe a lot of those colors in Russian or Chinese inside this English space that we worked. So what happens is we're going to hand files off and we're going to try to tell each device, whether it's a printer, a monitor, an iPad, a cell phone, anything that's going to display color, we're going to tell them what color is what and how to display it properly. And they do that by profiling. You create a profile, and those profiles are ICC profiles. Now this is just one gamut map. You can see that there's other gamut maps, like this one here represents on an iMac LCD screen the sRGB color space. So these are all of the colors that can be created on an sRGB space in white, and then these colors are the actual colors that can actually be viewed on an LCD. So if you bring that LCD and you transpose it into the sRGB space, you can see how much space is wasted inside that Adobe RGB space because the monitor can only view these colors. Okay, so the sRGB is a closer match for the colors on your 24-inch iMac LCD. So we'll go to the next one. These are different ones like an Apple iPad, okay, or a Galaxy Tab or an iPad 3, or we can look at some Transformer Primes. These are just different devices and their color spaces. So we'll look at this orange one. If you're looking at one of those Transformer Prime devices, those little tablets, I think those are the Android operating system, all of the colors fall within this space. So if you're working with Adobe RGB, which is in the black, it's gonna lose, the colors are gonna be wider than the display can even handle. So let's look at the blue one, the Apple III. If we're working inside an sRGB space, which is yellow, we're pretty darn close to where we can be because the iPad 3 is very similar to the sRGB space. So now let's look at these. These are just different ProPhoto and Adobe RGB color match and sRGB, and you can see where each one of them falls. And then these are greens, reds, purples, and blues, but not in a 3D sense, but in a 2D match or 2D map. Okay, so hopefully that you understand a little bit more about color. Now let's look at some images and how it may be affected, because browsers also interpret color differently. Some browsers are color managed and some aren't, like Google Chrome. Google Chrome is not color managed, where Safari and Firefox are. So they can view the color profiles that you have put up and interpret the colors correctly. So let's drop this down and let's drop this one down. So if we look at these images, you can see right off that there's a color difference between this image and this image. This one's Google Chrome and this one is Firefox. So we click on this eye here. Well, let me go back. Let's pull this one up. We're looking at two different images here. Okay, now this is the Firefox. This is using color profiles, and this is on my server. Okay, so I'm going to show you what Flickr looks like, and I'm going to show you what my server looks like. Since Firefox is color profile management, it looks at the color profiles and it will recreate colors based on that. You can see the differences in the hair. This is more accurate to the image that was made than this one. However, you'll see the way that this browser renders a file is a lot more pleasing. You see this moire pattern in the hair? It goes away when I zoom in, but the colors are rendering differently. You can see that there's more rich color here. It's more maroon and it's darker in the shadow areas. You can see around the neck the way the skin tones are. This is more orange looking and this is more pink. Now this is the way it looks on my monitor, which is color calibrated, and you should see a difference on your monitor too, even though the colors may not match. Okay, so if we look at the eye, we'll pull that up and we'll pull this up. Now you see the colors, they're pretty close, but you can see that maybe they're slightly more saturated in the colors over here than they are over here. And again, your monitor may not be able to see those differences, but I suggest you work in a color managed browser like Firefox or Safari. So let's look at some of these other images. These images here, these images represent Flickr, okay? And you can see that if we look at this side and this side, they're pretty close. I think the colors are a little bit more muddy over here. In the hat, like in the front of the hat, there's a little less detail. You know, this is all nitpicking, but there are differences in the colors. The eye, and this happens to be a self-portrait. Now let's look at these files from Flickr. Notice the moire pattern's gone. Now on my server, which is just reading the same file from Chrome, like here and here, Chrome and Firefox are reading the same exact file on my server, okay? And we have a moire pattern. This is the way that renders, the Google rendering engine versus the Firefox rendering engine. Now we're going to go to the Flickr rendering engine. This is the Flickr files, And you'll see that if we zoom out, the colors are pretty similar. Okay, but if you look at the way this is a lighter pink and the way these colors render over here are different. You can see the skin looks softer over here on the bone than it does over here. The face looks a little brighter to me over here than it does over here. You know, these are all subjective things, but color is being handed off and interpreted differently from different browsers. Okay, so I want to show you one last thing on color spaces. Sorry about that pause there. I had to pull these files back up. If you look in this top left corner, you'll see that this is the sRGB. These are all exported from Lightroom, and this is just an image. The center image is the original, and these are some different processing. Just playing around with different presets that I made. Okay, so if you look at the sRGB file, look at the colors, and we'll go to the next one. This is Adobe RGB. Now there's not a lot of shift in the colors. Matter of fact, I don't see any shift in the colors. Okay, so these were exports from Lightroom. Now we'll go to the next one. This is a Canon profile for a paper. It's actually a color profile, and here you can see there's definitely a color shift. This is an ICC profile. You'll see the blacks get darker, and it's a little bit milky here compared to that last profile. I'm not saying that's right. I'm just saying that there's a color shift, and that's what a profile does. An ICC profile will fix the colors based on the color space, a lot like a color gamut. Matter of fact, it works off color gamut. So let's look at ProPhoto RGB. Let me pull over it this way. Okay, there's sRGB. This one is a high gloss paper, and the way it needs to render ink is different than sRGB. So you can see the color shifts there. And let's go into the ProPhoto. This is ProPhoto color space, and there's Adobe RGB. I wish I put them side by side, but I didn't. Anyways, just to illustrate a point about colors, and I hope that the understanding of color now is more apparent to you. I suggest you work inside of a consistent color space that your monitor can reproduce and what your printer can reproduce with the proper profiles. Each paper is going to have its own ICC profile, the way it renders color. You'll need to use some type of device to scan a print and profile your monitor, whether it's a Spider or a Color Monkey or i1 Pro. If you're getting serious about your photography and you want consistent color, you need to manage that process. So I want to thank you all for taking time to come to my blog today, and until next time, we'll see you soon.